I'm going to record here. Okay. So I want to welcome everyone today to our second presentation as part of our Urban Agriculture Pest Management web series. This webinar series is coordinated by the Great Lakes Urban Agriculture IPM Working Group. This work is supported by the USDA National Institute of Food and Agriculture, Crop Protection and Pest Management Program through the North Central IPM Center, and we thank them for their support. A couple of just quick orientation issues to our Zoom presentation today. The presentation is being recorded, and we will send out that recording with the reminder for next week's presentation. So if you got the reminder yesterday in the evening, you will see that the recording from last week's presentation was included in that email. So that's how we're sending out the recordings. Just an orientation to the Zoom presentation today. To maintain this webinar quality presentation, everyone is going to be muted. You won't be able to unmute yourself, okay? And I will be turning off any videos that pop up so that our speaker has the floor in terms of the video. And so the only people you hear or see today will be myself and the presenter. Please use the chat box though. The chat box will be our way to communicate. So please use the chat box if you have questions or if you have issues with the technology today, and I can try to help you. Questions will be held to the end of the presentation, but feel free to put them in the chat box and I'll monitor that for our presenter later on. One other tip for the best viewing, you may want to navigate to your viewing options in the top right-hand corner. In my opinion, the best viewing is if you choose speaker view, and that will give you the best presentation look for today. And you'll basically see Laura and her presentation the whole time. Okay. Okay, so just for today's presentation, today's topic is composting with arthropods, including black soldier flies. Today we welcome Laura Ingwell from Purdue University Entomology Extension. Laura is an assistant professor of fruit and vegetable pest management, and we are really happy to have her and this fascinating topic today. So Laura, I will hand it over to you.
Thank you so much, Maggie. Okay, so hopefully you can all see this beautiful photo of my soldier fly here. So yeah, while the title was a little more broad, we are specifically going to be talking about soldier flies. And just to start off with, I want to recognize that the majority of what we're talking about today is work that was done by my master's student, Catherine Terrell, who just graduated this past May. But we also had the assistance of some undergraduate students, Jacqueline Eversol, Vanessa Cooper, Savannah Plessel, and a lot of guidance from Jeff Tomberland at Texas A&M. Part of this work was funded through the North Central SARE. My student Katie got a graduate student award to help support this research. And so what we're going to do today is talk a little bit about the background of urban agriculture and soil health and composting and insect recycling in general. Talk specifically about why soldier flies, why they're this new insect that I am totally obsessed with and very excited to share with you all today. And then I'm going to go through some of the research objectives that my student had and questions we tried to answer in terms of sort of what is the suitability of compost generated by these insects and some exciting future directions for this work. And so we really focused on the context of recycling and composting with insects in the framework of urban agriculture. I think everyone is here today because they have some interest or involvement in urban agriculture. So this is likely needs no justification for you on why it's important, but The reason we're really interested in urban agriculture, or extension in particular really wants to be supportive of urban agriculture, is that 80% of the population lives in cities. And the local food movement right now is really thriving. A lot of people are paying attention to where their food is coming from, how their food is grown, and the inequalities that exist around our food system. Um, Food apartheid activism in particular is really uniting diverse populations, organizations, groups of people in recognizing that we really still have a problem with food access, and especially nutritious and high quality food access. And so we need to work together as a community to try to address these issues. But there are a lot of challenges associated with urban farming that are unique in particular to growing in urban environments. The number one challenge is access to healthy, productive soils. And this is something that bleeds over a bit too into conventional farming or rural farming. But almost 70% of urban farmers struggle with land access. And so they're operating on small, very confined lots. That puts a lot of stress and pressure on that soil within the lot that they're trying to grow food off of year after year. And many times this soil has potential contaminants from exposure through resources that can be industrial resources, exposure of contaminants just related to high population and traffic. So things like heavy metal, pharmaceutical residues from using city water, all pose risks to the sustainability of farming in urban spaces. When we think about the ways that we can sort of remediate this soil health issue, we think a lot about compost, or generating new organic material that we can add to the soil to help build not only the nutrient levels, but the capacity for water retention and nutrient holding, the capacity to promote diverse biological communities in the soil. And we do that through traditional composting, whether that's anaerobic or aerobic mechanisms, but oftentimes that can require a lot of space. And there are a lot of perceived sort of pest issues around the idea of composting in an urban environment, where you may have piles of decomposing organic matter that are sitting for months, and other animals that may come in and contaminate that, or just the smell alone sort of being a nuisance to members in the community. The alternative is that we're buying this resource, buying topsoil, buying compost, buying other amendments, and transporting it into those urban environments. But this has a really high input cost, both economically and sustainably, in a sustainability context. And really, as we increase urban agriculture, urban production, and support for that, we have started to engage in larger questions about how sustainable is it to grow food in urban environments, and what does that look like compared to rural systems where we traditionally grow our food because of the land access and the land quality. And a lot of the questions arise around the inputs of farm materials that need to be transported into urban environments in order to produce this food. And so the broader goals of urban agriculture are identified here by 4 categories, I think, that sort of encompass most of it. The first is increasing food production in population centers so that we have a smaller carbon footprint related to transportation. If we grow food right where the people need it, then we can harvest it at its peak ripeness, and we don't have to transport it using fossil fuels. So we can reduce that input. We also want to reduce organic waste from entering landfills, and in densely populated areas, we have access to higher amounts or concentrated organic waste streams. We also would like to think about how can we improve the economic viability of small and urban farmings, and this can happen through diversification and creating value to some otherwise what may be considered waste streams. And we really, again, want to increase worker and consumer health. So fresh foods, safe working conditions for those who are producing it. And so what really drives me and my desire to promote and investigate composting with black soldier flies is in the context of this idea of generating a circular economy for urban agriculture. And so what do we mean here by a circular economy? Well, it's a systems solution framework that tackles global challenges like climate change, biodiversity loss, waste, and pollution. And so what I'm really thinking about here is that waste aspect. Where can we recapture some of these waste streams in highly populated areas and put value on that waste and put it back into our agricultural market? And so the three broader principles are eliminating waste and pollution, circulate products and materials, and regenerate nature. And as I hope to show to you today, black soldier fly composting really has the potential and the opportunity to address all three of these principles of circular economies. We also have some enthusiasm and basically necessity to farm in urban and peri-urban areas, which is driving more resources and investment into this. The advantage, I think, for the composting and generation of new organic matter to put into agriculture comes from this diverse base of organic waste streams that we can find, and really high quantities of this organic waste. And so in densely populated areas, you can find a lot of usable household food waste, food industry byproducts. So this could be like the scraps from the preparation in the kitchen, or the food scraped off the plates from consumers who may not be able to eat all of it. Restaurant and grocery store waste, and garden or farm waste. So I think that there's a lot of volume here available in urban centers. And we really have a lot of research advancing in the field of insect husbandry. And that's how we've been able to identify black soldier fly as an ideal candidate. So why the black soldier fly? What is this and why is it so cool? Besides the fact that they're absolutely beautiful, I think, especially for a fly. Let me try to convince you. So their life cycle can be completed in as little as 44 days. They are a true fly, and they go through what we call complete metamorphosis. So you have this adult fly here, which does not eat as an adult. It does not transmit diseases. It's really benign and short-lived. And really the main goal for adults are to reproduce and lay eggs and then die. So they are only alive for a few days. They're very clumsy flyers, and we don't have to worry about them as a pest in the sense that we do with some other fly species. So the adults mate and they lay eggs. Those eggs then hatch and go through a series of larval instars. Oftentimes for flies, we refer to these as maggots, although maggot has a negative connotation. So I like to stick with larval instars. But so they progress through a series of larval instars, getting larger and larger as they do so. And as they're growing, they are surviving on organic materials, so organic waste materials. They are decomposers or detritivores, as we like to call them. So they feed on dead decaying matter or decaying organic waste. And then once they reach this fifth instar, they naturally move out of the food substrate and look for a dark, dry place to pupate, which is a lot like the cocoon stage for caterpillars, but it's this resting stage before they become an adult. And so they move out away from their food. They look for this dark, dry place. They rest and then emerge into adults. And so this whole larval development takes about 21 days. So if we want to talk about the process of generating compost, they are feeding on organic matter and generating excrement, frass, poop, as they feed. And so within 21 days, what you can do is generate this new organic recycled material and be able to harvest that digestate or compost created by black soldier flies. So much quicker than traditional methods. They thrive in a temperature range of 24 to 40 degrees. So they are native to the neotropics and persist in southern portions of the United States. As you move more north, they migrate up in the summers, but cannot successfully overwinter. So you may find them in our regions, Illinois, Indiana, Ohio, later in the summer and into fall. But in winter, they cannot sustain. Their ideal humidity levels are between 30 and 90%. And there are some really interesting benefits that we've been able to observe in terms of what happens when they're feeding on these organic materials. One really exciting thing is that they can reduce mycotoxins and pesticides in the substrate in which they're feeding. They also have the capacity to reduce pathogens like E. coli and Salmonella. And in some studies, even they've been shown to alleviate the bioavailability of heavy metals. And so there's a lot of promise here for potential environmental remediation and recapturing of what's the word I'm looking for? Sort of contaminated organic materials and being able to put them back into our food production system in a healthy and safe way. So this is sort of what our circular economy model of integrating black soldier flies into farming looks like. And so I'm going to break this down for you a little bit. First, what I want to focus on is the fly itself and its life cycle. We have three really different and main components here. We have the adults themselves, which we want to promote so that they can lay eggs and build up the population. We have the BSF larvae. So they are the ones who are doing the eating and the decomposing and the pooping here, which is the frass, generating that organic waste material or compost. And then the larvae themselves and the pupae can serve as another component in this system that has value. The way that we can generate and promote these populations or utilize these insects is by capturing some of these waste streams that may otherwise go into the landfill. So this includes things like manure. So in our research here, we used sheep manure, but soldier flies have been used to break down or process human feces and manure from all different types of livestock. We can take food waste that would normally go to the landfill and move that back into the system. And the unique thing with soldier flies is that they can feed on and efficiently and quickly break down foods that can't go into traditional compost. So things like animal byproducts like meats, cheeses, yogurts, things that are high in fat like salad dressings, oils, oil waste from fast food restaurants. These are all materials that these flies have been shown to be successfully reared on. And then we have the plant waste itself from the food production. So this is the leaves and stems or culled fruits from a farm that never make it to someone's plate. And so here is where we're taking something that would normally go into the trash and we can put an economic value on it as a food source to raise this insect. Then we have the byproducts created by this insect themselves with a value added to put back into the system. So first of all, the focus today is on the frass or the poop in the digestate, which we can use as a fertilizer and soil amendment to continue to grow food and plants. But the other valuable product is the insects themselves. And so you can produce really high populations and have excess larvae and pupae, which are really high in protein and fat and have been shown to be a great source of feed. And so that can go back into feeding the livestock that you're generating the manure from to go into the flies themselves. And so I'm not talking about this today, but there is a very large body of literature growing about the feed quality of black soldier flies. And so we have 3 studies here comparing the nutritional quality of soldier flies to commercial formulated chicken feed. And one of these studies is from my student herself. But what we're seeing is at least twice as much crude protein and 4 times as much crude fat derived from these insects as opposed to traditional chicken feed. So really a nutritional supplement that is great to incorporate into livestock production. But what I want to talk to you about today is looking at the application of this for compost and specialty crop production. So what we did in our research is evaluate different feed stocks for the soldier fly development. So these were identifying organic waste streams that would be readily available in an urban setting and seeing how well we can grow the flies on them. Then we took that digestate that the flies produced and we applied it in the field production of 3 different specialty crops and looked at how those 3 different crops can react or benefit or not from the application of this digestate in comparison to a commercially available composted cow manure. And then lastly, we had the opportunity to deploy some of these composting bins on farm with participants, and we share a little bit about their experiences. So we examined processed food waste, which includes bread, rice, and cooked items, organic food waste, so this is the raw food products, or plant waste, so fruit and vegetables that were culled or weeded out of the garden, spent worts, which we got from a local brewery, and sheep manure. And we fed the insects on those sole sources of waste stream and compared their development. So we measured things like larval length and weight gain. And what we're showing you here is the average larval length of the flies themselves. And we have this broken down by all of our different feeding trials, so you can see the variability. But here's the biosolids or sheep manure in the sort of poo green-brown colored bars. The organic food waste, which was mostly plant material and raw fruits and vegetables in the green bars. The processed food waste, so this is scraping what's left from the dinner plate into the compost bin in blue. And then the spent worts in this golden color. And we see high variability among these treatments, some significant differences from one treatment trial to another, but the bottom line is that the flies did survive and reach maturation on all of these diets. Organic food waste and processed food waste, we seemed to observe in the bins themselves that the flies were doing really well on that, but we had one trial here that we refer to as the hot dog trial, where we had a lot of extra hot dogs that we inherited as feed. And you can see that here in this second trial, we see a dip in their production and productivity, and we could really tell in the quality of the digestate as well. The diet wasn't as diversified and really consisted of a lot of hot dogs, which is not the greatest, but they ate it. And then if we look at their growth rate over time, we do see the fastest growth occurring on the plant food waste, again, in that first, or the processed food waste, I'm sorry, in that first trial. But when we went hot dog heavy, we see no differences. So they're all growing at about the same rate. Spent worts was the slowest, but again, they all reached maturity and we were able to recover usable product at the end from all of the individual diet streams. If you were interested in sort of this dual purpose of composting with black soldier flies and you wanted to recapture the flies themselves as that feed resource, we do see differences here where you're going to be getting higher weight, larger larvae from the processed food waste and the spent worts. So this is something you might want to take into consideration if you were also trying to recapture that protein aspect and feed aspect from the flies themselves. And then we see this a little bit reinforced here over time, looking at how quickly they're gaining that weight. And we're seeing that the larvae that were fed the processed food waste are gaining weight the fastest and reaching the highest weights compared to the other diet streams. Again, even when we put in that hot dog factor in our second and third replicates or renditions of this study, we are still achieving higher weight from the processed food waste and the spent warts in this case compared to the others. And so besides looking at the larval performance and the fly performance within these different sole source diet streams, we also wanted to look at the quality of the digestate or the compost produced. And so what we did here was we collected this digestate after the larvae have fed on it. And in some cases, it was still pretty coarse. And so we put it in a blender and chopped it up a little bit. And we sent these samples off from these pure food sources to a laboratory to get a compost analysis done. And what we're showing you here is the value of nitrogen, phosphorus, and potassium, or NPK, that was available in these digestates. And as a control, we're using black cow composted manure. And so I do want to say that we don't anticipate that this compost will serve as a nutrient supplement or a fertility supplement. We do recognize that this is one metric to evaluate sort of the quality of this digestate. There are many other factors that we can look at as well. But we want to point out here is that processed food waste is where we're getting the highest level of NPK. And the percentage is almost 1.5 times that of black cow in terms of nitrogen, and really, really highly variable amounts of phosphate and potash, which are the two forms of phosphorus and potassium that we're measuring in this test. And so we do see that the input in terms of what the feedstock is has an impact on the quality of the digestate. But regardless of what that feedstock was, it is equivalent to, or in some cases superior to, that was measured in the composted cow manure. And so we were able to show here that you can grow soldier flies on a variety of feedstocks. They can adjust to prolonged periods of starvation or variable rates of feeding or quality of food, but they do eventually make it to adulthood. Maintaining moisture is really key in terms of accessibility of the food you're putting in. They have a scraping mouth part that they use to break down this food. So if the food gets really, really dry or coarse, they don't necessarily have access to those nutrients. So looking at the relative humidity and just testing with your hand the moisture levels and adding water when necessary to make that food more accessible is important. But we do feel pretty strongly that this is a pathway to reduce organic waste, to capture what would normally go to a landfill and convert it to a soil amendment in a fairly quick manner compared to traditional composting. Then what we did is we took those single source waste streams and we mixed them all together so that we had a large sample of what we broadly call black soldier fly digestate. So that was the digestate generated from spent warts and processed food waste and organic food waste and sheep manure all mixed together. And we then took that out to our research field at MIGS and we applied it to 3 different specialty crops. And we did this in a randomized block design with the application of black soldier fly digestate compared to a equal volume application of black cow composted manure or no additive amendment at all. And we did this across 3 different crop types: celebrity variety tomatoes, short and sweet and navel variety carrots, and Tyrea cucumbers. And we were interested in measuring a variety of different plant metrics: the height and length, stem diameter, insect pest pressures, and ultimately plant biomass and yield. And so just so you know what this looked like, we worked in one large field at our research farm, but we blocked crop types together. So cucumber was planted in 2 rows, navel carrots in a shorter 2 rows, and then celebrity tomatoes. And within each of those rows, we randomized the application of the amendments to smaller blocks within the row. And so first we're going to look at how did the yield of these crops turn out in relation to these different soil amendments. And if you look at cucumber and tomato, what we see is no detectable differences in yield, which is promising because in this case you're saying, unfortunately, we didn't see any benefit from having an amendment at all compared to no amendment. But at the same time, black soldier fly could serve as a substitute to black cow compost, and you see the same or sort of no benefit in the production. But then we wanted to look, okay, not just yields, there are a lot of other plant traits we can measure. So what about the actual biomass or volume of the plant? And what we see here is just a slightly significant impact on tomatoes. And we actually see lower above ground biomass on those plants that had black soldier fly compost amended to them in comparison to black cow, which was not different from the control. So while the plant itself was smaller, it still produced the same amount of tomatoes. Then we went to below ground, right? So the amendments themselves were applied as a side dressing. So we put the crops in first, then we came back and we added the compost amendments. And what we see here for cucumbers on the left is that the black cow and soldier fly amendments did not differ from one another in terms of what the below ground biomass was for cucumbers, but both of them were larger than that of the control. So we're getting the same level of response to either soil amendment, which is good because it suggests that black soldier fly amendment can perform in an equal way as the cow manure. We see the same thing with tomato in terms of black cow and black soldier fly amendments were not different, but in this situation, it actually reduced the below ground biomass, and we saw that the control plants had larger below ground biomass. And we could attribute this to the fact that this plant needed more nutrients and the root system developed larger in the control plots because they were scavenging for that nutrition and had to build a larger root structure to get what it needed out of the soil, where in those amended plots, it had everything it needed right at the base, so it didn't have to be searching and investing more in root development. Carrots were interesting. We had differences between the treatments, but we expected that because one of these varieties, navel, is sort of more of the traditional carrot, and short and sweet on the right is a dwarf variety. So we expected that this short and sweet variety would be smaller and more compact. But the most exciting part is that in this root crop, we see the highest advantage and statistically significant difference with the black soldier fly amendment. So this crop seemed to benefit the most in directly improving the yield of the portion of the plant that we are harvesting and selling. Carrots that had black soldier fly larvae or black soldier fly digestate amended at the root zone grew larger than those that had composted cow manure or nothing added to the root zone. So to sort of review what all of this means and compare one crop to the next, because we did see differences, I constructed this table to sort of summarize it. So what you're going to see here is we'll start with cucumber and then we'll review tomato and carrot. But what we're going to look at is yield, above ground biomass, below ground biomass, plant height, and stem diameter. And the yield, we see it trending toward an increase in yield for cucumbers when soldier fly is added. No difference in above ground biomass. Black cow and BSF both were higher for below ground biomass than those that received no amendment. We saw slight increases in plant height with soldier fly and slight increases in stem diameter with soldier fly amendments. So in general, cucumbers seem to benefit from this amendment. Moving on towards tomato, we see the opposite effect. We see a trend towards decline when this is added to tomatoes. No differences in plant height or plant stem diameter, but we do see that the black soldier fly amendment actually had the lowest above ground biomass and performed the same as, but was lower than no amendment for the below ground biomass. And we see the greatest benefit to carrots. And that's where we see the highest yield when black soldier fly is added. And so thinking about the crop that you're growing and maybe where the utility of soldier fly digestate would be most beneficial is something important to note. Here we're comparing soil samples that we then collected from the fields after we put this, or actually this is the amendment itself in another compost test. And what we see here, that looking at the black cow composted manure and the BSF digestate, looking at, again, those nutrients that are available in terms of NPK, we see that it's much higher for the BSF digestate compared to the composted manure. But again, this isn't enough to feed the plant outright. We also see elevated levels of some of these micronutrients. But one thing that one more benefit, organic matter. A lot of times we're adding this to the soil to increase organic matter, and we see almost twice as much organic matter available in BSF digestate compared to black cow. So we really think this may be one of the best benefits, is building organic matter in the soil. But two things to watch out for that may be a bit concerning and likely directly related to what you're feeding those flies is the pH of that final product and the soluble salts that are available. Some plants are very sensitive to salt levels, and sometimes in agricultural soils that are under high pressure, you end up building up, getting a high buildup of salts. So salt is something that you have to watch for. And so you should always be testing your digestate. But overall, we see benefits from soldier fly composting. It can increase organic matter content. It can help with stabilizing pH, and it provides a lot of micronutrients for the plant. And so the last thing, quickly, so that you guys have some times for questions if there are any, is that we did have an opportunity with this grant from SARE to build some bins and send them to some collaborators and get their feedback on the process. And so we built 18-gallon or 50-gallon bins. We built them out at our research farm, and then we deployed them to 10 collaborators throughout the state. And so what you can see here, our collaborators were located in some of the higher densely populated urban areas. And so we gave them the bin, we gave them larvae and some instructions and said, have at it, let us know how it goes. And so some of our larger farms chose to use the 50-gallon bin, and then some of our smaller farms or sort of educational institutes chose a smaller bin where they maybe didn't have as much space or need to create as much digestate. So that's all I want to say about the bins themselves. So 5 of each were deployed for 10 total participants. And we asked them, how would you rate your experience? Overall, we had great and excellent ratings in terms of the durability of the bin. Kind of mixed results. And so, sorry, that's the red line. In terms of the user friendliness, great was the better response, excellent to great, but a few that thought, oh, maybe not so great, or it was just okay. The design of the bin was just okay, so we have a lot of work to do there. And the compost quality results were kind of mixed. That's the green bar. We asked them if they made changes to their bin, and 7 of our 10 participants did. And so what those changes included were drainage holes because they had issues with moisture retention and standing water, a kickstand to hold the bin at an angle so it could drain on its own, inserting cardboard, which we recommended they do to help collect eggs so that you could maintain recolonization in your bin. So the adults prefer to lay their eggs on the cardboard. A screen inside the drain spout so that you could keep sort of the larger chunks inside and not plug the drain spout that we had provided. And so this is what it looks like. They really prefer to lay their eggs near but not in the food. So the cardboard eggs, if you put corrugated cardboard near the substrate, you'll end up with adults laying eggs, and that's the little yellow things in that cardboard. And then we asked them if they will continue to use their bin beyond the duration of this project, and 7 again of our 10 participants said probably or definitely yes, which was really encouraging for us. Then we asked, well, would you recommend it to others? And 4 said definitely yes, and 2 said probably yes, while we had 1 say probably not and 2 say might or might not, which is interesting because overall they weren't necessarily satisfied with the compost quality, but it shows that they had fun doing it. And just 2 sort of testimonials I want to share with you. One of them is that one of our participants made this observation. They particularly relished soft-bodied vegetables like tomatoes. Bread and pizza were very appealing. So it was fun to hear from them in terms of what they were putting in the bin and what the flies sort of preferred to eat or not eat. And then another participant had livestock on her farm as well. And so she shared something really cool with us. She said that she was raising meat chickens and ended up needing to cull 2 of them. So 2 died early on, about 3-pound chickens. She threw the whole bird that had died right into the top of her soldier fly bin. And she wrote, the BSF larvae ate them, feathers, bones, and all, in about 2 to 3 days. It was super impressive. She went on to talk about how in the future she'd probably cut up the carcasses so that it was more easily digested. But that also brought up the application of soldier flies for carcass digestion and carcass cleaning up when you have livestock that perish. So the future of this work is to improve the bin structure. The pupae are supposed to exit and leave the bin on their own. We really struggle with really getting the vast majority of them out, which can make harvesting a little bit difficult. And so again, that's another aspect of the bin structure, is an easier way to harvest the digestate. We're also really interested in evaluating the food safety aspects of this digestate, right? If we are really going to recommend using it in sort of commercial scale in farm production where that food is going out into the community, we need to understand potential pathogens related to specific feedstocks that you put in the bin and the safety of how long it may need to age beyond the flies digesting it to make sure that it's safe to put on edible produce, and then work towards increasing adoption and making this accessible for others. And so with that, I will stop and look at the chat and take any questions. I might leave the flies up for a little bit because they're cute and you can look at that instead of me.
Absolutely. So I had a question come in directly to me. Don was wondering about, you mentioned a few different like toxins and heavy metals that they have shown some effectiveness in removing or alleviating. He was wondering about pharmaceutical and if there's been any research into them,
Yes.
get the pharmaceutical waste out of.
Yeah, so there has been research in that field, and that's related to, so black soldier flies have been applied as a way to process wastewater gray water or like municipal water, right? And so a lot of times you can get pharmaceutical residues in the water stream just from people's waste products containing residue or people flushing pharmaceuticals down the drain to get rid of them. And so, yes, it has been shown. I don't remember what the chemicals were, but there were 3 different drugs in particular that were studied. And what's really exciting about that in terms of the pharmaceuticals and the pesticides is that they're actually decomposing those molecules. So they're breaking apart the molecules into smaller components. They're not accumulating it within the insects themselves. So you can still use the insect as feed. It's not an issue of bioaccumulation, but it's actually what I would consider remediation and breakdown. They're breaking apart the chemicals into smaller pieces, and so it's no longer intact. And so it can be used to create clean water, and you can still use the flies or maintain the flies in the environment. I don't know how it happens, but there are a couple papers. You should look it up.
Amazing. One other question that was in the chat box, and please, enter more questions. I kind of dare you not to have questions on this topic because it's so interesting. Carolyn was wondering, she said that her compost bin has become populated with black soldier flies each year. And it 1 year and it's occurred every year since. Is this a new population that's finding their way there every year, or are they somehow overwintering? She's in Dublin, Ohio, which is central.
Okay, I was just gonna say, I don't know where Dublin, Ohio is.
Mhm.
So at this point with my experience, I would guess they are recolonizing. And I say that because this year in particular, we went back to the larger bins that we had and looked for overwintering. I would have expected that if you have a large pile, if you have pupae in the middle of that pile, they would be insulated enough that they would be able to overwinter and survive. We could not find any that had successfully overwintered, and I didn't measure the temperature in the middle of those piles. But I even know from experience, if we put them out in spring too soon and we get like a frost, a cold snap, they all do die. But that's still a big question, really, in terms of how cold hardy are they, and do we have some local populations that may be more adapted to that environment? And so there are other types of soldier flies that we see even further north in Michigan that may be a more cold hardy alternative to black soldier flies, or we may find some local adaptations, but we really just haven't looked yet, so don't know.
Kind of off the same topic, I was wondering, so how do you acquire black soldier flies? Is it something that you can purchase, like red wigglers?
Yes, yeah. So the husbandry of soldier flies is a really large market for pet food in particular. And so if you have like reptiles as pets, soldier flies are a superior feed source compared to mealworms and crickets because they have a much higher phosphorus to calcium ratio. So it helps combat this bone disease that reptiles can get if they're not getting enough calcium in their diet. So the bottom line is a lot of people rear them and sell them as feeder insects. And so you can just search online black soldier fly, like live black soldier flies for sale. We usually purchase ours from Pop Worms out of Texas. Flukers, which is in Ohio, I think, for a while was growing them. They may have stopped now, but yeah, you can definitely buy them online. I now have a colony that I maintain indoors to work off of year round and use to restock. But for a homeowner, just buy them and they're not very expensive. I see another question in the chat about, are the bins turned or mixed? They are not. And so in a very similar fashion to vermicomposting, where the worms are doing the turning for you by moving through the substrate, the soldier fly larvae do the same thing. They migrate up to the top of the bin, to the surface when they're feeding, and they'll feed for a bit of time during the day, and then they migrate down and they rest. And so they do that turning for you just by moving through the substrate. So you do not have to turn it.
Okay, I have another question. I've got all the questions today. So it seems like it's really effective with the processed food waste. It seemed like there was a lot of advantages to using them to compost those materials. What is like the stinkiness factor with that material? Yeah, I don't know how to quantify that, but
Yeah, no, I will tell you that it can get nasty. It can get nasty, especially when you feed them 10 pounds of hot dogs. So really the key to controlling the odor is around the rate at which you're feeding the flies. And so I am almost done with a guide that will be available through our extension that gives you sort of a guide for feeding in terms of how many pounds per day they can eat in relation to your population size. But in general, if you watch the population and you add food as it's being consumed, you don't have the stink factor. And you can put in things like meats and cheeses and cooked noodles, and they eat through it so quickly and they outcompete any other organisms that may colonize your bin. So it stays very clean and dry and it doesn't have a smell. I mean, it smells like a healthy compost.
oh,
If you start to overfeed, where you have that food waste sitting for a couple days, more than the flies can get to, then you start to get other bugs or stink that move in, and it takes time for the flies to then eat that and break it down. And so I recommend feeding them like every 2 to 3 days. Don't put like everything that you expect them to consume in their 21 days in at once, because then you can get some odor issues. But you would be amazed at how quickly they can go through that material.
amazing. Yeah, feel free if you have any other questions. I'm just going to keep asking mine until someone else puts anything in the chat.
I was going to just before you move on, Maggie, I have this table in front of me. And so we usually buy a bin of like 10,000 maggots and it comes in a little cup. And so if you have 10,000 maggots, they will eat on average 4 pounds of food a day. So that's like a bag of apples in terms of weight quality. So it's quite a bit of food. And they will do that, I would say, reliably for about 15 days. And then when they get close to maturation, that feeding rate slows down.
Okay. It takes a lot of monitoring of the population.
Which if you have it in, a place where, if you have it in a place where a lot of people are around it, monitoring it is good. I have one in my backyard and it's far enough away that I throw a ton in there, and if it gets a little stinky, that's okay, because the flies will eventually break it down and clean it up. And so they are pretty tolerant in terms of letting it get out of balance, and it will remedy itself.
Okay. Jean put another question in about, is it fast? It sounds like it's faster than passive composting. I guess specifically when you're dealing with mostly of the organic or raw food waste and plant material.
Yeah, so someone could correct me here if I'm wrong, but if you rely on traditional aerobic or anaerobic composting, you have to think about stopping adding to that feeding pile. And I believe it takes close to 50 days, depending on, the environment and the temperature, for that breakdown process to happen, usually longer. If you are feeding the flies, they complete their development in the larval stages in 21 days. And so when they reach that maturation, if you are watching the bin and taper off your feeding as they slow down, you can then harvest that bin at the end of 21 days when they start to migrate out and the pupae leave the substrate.
Okay, so just a few different factors you have to take into consideration. But it sounds like it's faster.
It's much faster. Yeah.
hold back on the material that you're putting in. Not as easy as just throwing everything in a pile, I guess, but yeah. Are there any food items that should not be added other than too many hot dogs at one time?
The things that they have trouble with are really, really hard materials. So you saw, like, I work on sweet corn, so we threw a lot of sweet corn into the bin. They can never break down the cob. They will clean out every bit of corn kernel within there, and what you're left with is that really, you know, hard fibrous cob material that they can't get at. And so I still put it in the bin, but then I just know that when my compost is mature, there's going to be a big corn cob that I have to take out, but they will eat every single kernel that they can get to. We put a lot of melons in our bin as well because we work on melons. So like the rind of cantaloupe and sometimes the very, very outer skin of apple, they can't break down that material. So you'll get these like flaky bits in there. But what's interesting is we did a study with a weed scientist looking at sort of weed seed viability and germination. And I don't know whether it's them feeding on the seed coat or the temperature that is reached when they're feeding in the compost themselves, but we see suppression of weed seed germination when soldier flies are in the compost. And so that's something that's really interesting and encouraging to see.
Absolutely. Carolyn says
They like to eat out too.
Absolutely.
They do love watermelon. Anything that's really like soft and accessible for them. Watermelon is a really good one. Strawberries, but strawberries rot so quickly. Like if you overfeed strawberries, they smell before the flies eat them all. So that's one I do with caution, or I put them in the bottom of the bin, not on the top, so that you don't get that smell. Yeah. Water is a big one that can be an issue sometimes, and you saw that with our participants, the bins will get standing water. You can eventually drown the flies, but they are pretty good usually about crawling through the water and crawling up out of it. So if you do have standing water for a few days in the bin, it will start to smell, but you can drain that water off and the flies will continue to feed.
What about the digestate? Is that commercially available for gardeners?
I have found one source online so far that I believe it's Arbeco Organics actually, where you can buy BSF digestate, just like you can buy vermicompost castings they call it, right? Yeah, so you can already buy it commercially in small quantities. It's exciting. There's a lot of research happening in terms of plant defenses too, and the benefits of BSF digestate. It's really, really high in chitin, and there's research showing that when you add high amounts of chitin to the soil, it primes the microbial community to attack like fungal diseases in the soil that have like a chitin exterior. And so it's called a disease suppressive soil. But there's some really exciting work about, increasing sort of the disease hardiness or combativeness of the microbial community in the soil by adding this chitin-rich digestate.
It's almost surprising it's not more available, since you said that the husbandry is really, that industry is out there.
Yeah, it's around regulations, I think, to sell it, from what I understand from the industry. And also they are very efficient. So you don't get a large volume back, right? They break it down and you'll start with, I don't know, in a 50-gallon drum, it's half full, so 25 gallons, and then you may harvest like 2 or 3. They're really efficient at breaking it down, but a little bit goes a long ways. Okay, I see one last question here. What other insects are being investigated by you or other researchers? in terms of compost or nutrient recycling, Michael Crossley at the University of Delaware is the only other person I know that's looking at an insect other than soldier flies in this context. And I can't even tell you what it is that he's looking at. It's a beetle, I believe. Stay tuned. This is really a new field. He's going to be talking about it at our entomology meeting this year, so I'll know more then, and hopefully we can bring it back to some extension materials. But yeah, watch for Delaware, the University of Delaware. There's a program building there that's doing something similar. And that's in the context, I think, of livestock production, and they have a lot of livestock waste materials. And so using this insect that's been found in poultry production in particular to help break down that waste and then harvest that insect. Well, thank you, everyone. This was great to have questions, and I love talking about soldier flies. They're so cool.
Yeah, absolutely. This was really fascinating. And it's cool to be keeping track of it and seeing where it goes. I think it's just going to be really interesting to watch. So yeah, thanks everyone for attending this presentation. So just so you know, we have one more presentation in our series. That's next Friday. We're going to be joined by some colleagues from Cornell who will be talking about scouting for insects into your own garden or urban farm, and also kind of trapping and what's the concept of trapping when we're talking about insects and how that is really used to manage your insects in your garden. Okay, so yep, that's it for today. So thanks everyone, and thanks Laura especially for presenting today, and hopefully we'll see you next week. Okay,
thank you, Maggie.
Yep, bye-bye.
Bye everyone.